So what's the natural log? What's the natural log of infinity?
Infinity.
Infinity. What's the natural log of infinity?
Infinity plus 1.
Infinity plus 1, which is still infinity. And that's your indeterminate form. So when you have an indeterminate form, what's the first thing you think of? L'Hopital's rule, where the x is silent. So we're going to do that. So then you get limit as x tends to infinity. And then what's the derivative of the natural log of 3x plus 5?
1 over 3 plus 5 times 3.
So I'm just going to put it as 3 over
Oh, that's right, you can do that.
3x plus 5. And then all of this over, what's the derivative of the denominator?
7 over 7x plus 3.
Perfect. 7 over 7x plus 3.
Mm-hmm.
All right. And then you can again try to substitute an infinity. So what do you get?
Infinity over infinity. Wait.
Is it an infinity over
No.
infinity? So what's 3 over infinity? What's anything over infinity?
It would be going towards, it'd be 3 going towards a really big number going towards 0.
It would go towards 0. So if you have 1 pi and you divide it an infinite number of times, how many pieces does each person get? Or how large would the piece be?
Very, very, very small.
Very, very, very small, exactly. So almost negligible. So 0. So you get 0, and same thing, the denominator, you'll get a 0, because it's something divided by a very, very, very large number. All right, so you have 0 over 0. What do?
Do it again.
You do L'Hopital's rule, and then do you have to do the quotient product?
Do you have to do L'Hopital's rule?
No, you can just do the quotient product.
Quotient.
Or quotient rule.
What's the quotient rule?
The 3x plus 5 times the derivative of 3 minus, oh no, I'll just give you bigger fractions over fractions, never mind.
Can you simplify?
Can you multiply
Yes.
by like the reciprocal?
You can multiply by the reciprocal. So in this case, what would you get?
3 times 7x plus 3 over 7 times 3x plus 5.
3 times 7x plus 3 over 7 times 3x plus 5. And you do not want to forget the limits. Nick, do you get how we got there?
Basically you just multiply the top and the bottom. Not really.
So, okay, what I like to do
Just to be
when,
honest.
no, that's totally fine. I mean, even like, I need some help here sometimes. So what I like to do is find the common denominator. So for example here, if I wanted to get rid of the 3x, if I wanted to get rid of this fraction, what would I multiply this by?
3x plus 5.
3x plus 5. And then I would have to do the same thing for the denominator, right? Now if I wanted to get rid of this fraction, what would I do?
Okay.
So, yeah.
Nice, yeah.
Okay, so you get this. So what can you do here? Does this look like a more familiar problem in which you can find a simple answer? So you've got an infinity. So what can you do here?
Factor out the largest.
Factor out the largest factor.
Yeah.
So that would be x. So then you would get 3x. Oops, let me just draw it right there. So then you would get the limit as x tends to infinity of 3x all times 7 plus 3 over x all over 7x times 3 plus 5 over x. Cool. So what do you do from here?
The 1s over x come to 0.
The 1s over x goes to 0. So 3 over x, 5 over x both go to 0. And then what can you do with the x's here?
Cancel them.
You can cancel the x's. So what are you left with?
3 over 7.
Are you left with just 3 over 7?
Wait.
It'd be 3 times.
Oh, 23 over 21.
Yep, you don't want to forget those. So 3 times 7 will get you 21. And then 7 times 3 denominator will get you 21.
So 1.
So your final answer is 1.
I knew that.
Yeah.
whenever you do all this work and it's like,
1.
it's always like 0, 1, or 2, and you're just like, no.
It's just like a tiny answer.
Like really.
Yeah. I know it looks like pretty complicated, but
It's like that's the sad part. It's not like none of
Yeah.
it's complicated. It's just like processes on top of processes inside of
Yeah, I'll
processes.
just, yeah.
I think it's just you guys thinking too hard about what you took last class that you want to apply it here, but you really don't have to all the time. Like, you just had to use L'Hopital's here once, and even that's arguable. Like now you guys took the rates of change. Now, if you know about the rates of change, then you know that both of them increase at the same amount.
Because it's constant.
And so it should be just a constant, right? So like that's another way to do it. You could just be like,
Because you know that the ln of x and ln of x, well basically since they are both ln of x, they would go to the same.
yeah,
Even though it has +1, it's still going to the same.
yeah, exactly. Because this is a limit that tends to infinity. So whenever you see a limit tending to infinity, you can always use the rates of change.
Oh.
So honestly, for that problem, you could just write it's 1 because the top and
The
bottom
natural
are
log.
both increasing at the same rate.
Well, it can
Yeah.
be, I thought it, you don't really know it's 1 though, because it can be any constant, can it?
What coefficient is there though?
But I'm saying like like,
Oh
In
yeah,
my
I mean if you
final-
had a 2 here,
yeah.
then
so
your
then-
final answer would
uh,
be 2. It wouldn't be
Yeah.
1.
Wow, what a trick. What a trick.
What a trick, right? It's just a nice thing. I mean, I would still use this on the exam because I don't know. In 141, you can definitely use the rates of change. But as of now, I would go through it and just use the rates of change to check, just to like double check your answers.
I wish I had time to check.
You will with practice if you keep